Hello, everybody, and welcome to this webinar. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section at any time during the presentation. The webinar will be recorded, and in a few days, we will send you the link to the recording. Next slide, please. Today's topic is web-based digital thread for systems engineering. And this is the agenda for today. First, we will have a short introduction to the company and the presenters. Then we introduce the new web-based digital thread for systems engineering. After that, we will see the authoring web edition and the seamless integration with web-based engineering tools. Next, we will see the digital thread analysis tools, and finally, we will have some time for Q&A. So let's start with an introduction to the company. What do we do at the Reuse company? We provide a platform and a set of well-defined methods to support the implementation of an incremental and comprehensive reuse process. The approach is based on knowledge management and elicitation, quality assessment, interoperability across tool ecosystems, artificial intelligence, and smart search engines. The presenters today are Luis Alonso and Iker Gonzalez. Luis Alonso is the consultant director of the Reuse company and has also been the chief software architect. Iker Gonzalez is a consultant at the Reuse company. So let's start with today's topic. Hello, Luis and Iker.
Thank you, Cecilia. Very well welcome to anybody there. Okay, the topic for today is to introduce our new web approach for the digital thread in systems engineering. Systems Engineering Studio is a tool that provides leverage activities that are developed across other tools in the ecosystem of systems engineering. Systems Engineering Studio is not designed to replace the concept of single source of truth. The idea is to keep all the different activities in all the specialized tools, which they are the best ones to perform such activities, but to interoperate, to enhance the communication among all these set of tools. So in order to do that, we offer connectivity to more than 50 different tools for many different domains of the engineering: requirements management, model-based systems engineering, application lifecycle management, product lifecycle management, even Offimatic suites such as Microsoft Office, or even Exchange documents such as PDF. The idea is to enable the interoperability and traceability among all the different assets generated and managed through, across this toolset in this ecosystem. So having your digital thread together as a synchronized source of truth. Now it does not, the information does not belong to one tool, to one team, but to the whole project, and they all must be synchronized and coordinated. And this is the approach that Systems Engineering Studio enables. And the kind of activities that this tool allows are to facilitate the digitalization of the technical management process and the technical processes of the systems engineering. We have implemented and digitalized several, like the ones displayed here, and many others to come. And what is the new approach right now is that we have created a web edition of the SES Engineering Studio that allows to seamless interoperate with other web tools, for example, JIRA, and allows us to introduce directly the information in JIRA on top of reuse semantic capabilities for authoring. Now also with capabilities of traceability assistance, and also it enables to the final user some other digital threat tools, such as global impact analysis to examine the situation of your digital threat across all the tool ecosystem, to execute orphan analysis to detect missing parts in your ecosystem that are not related to the others, but they should be, and also to even improve this analysis, we generate a semantic search capability on top of your ecosystem in the synchronized source of truth to look for impact analysis, for change assessment, and also for improving your global impact analysis, not to leave out any relationship that you may have in your projects. The idea of having the web and the desktop is to combine the easiness to generate all this linkage between different assets in different repositories using the web, and the power of the desktop edition to create synchronization with other sources of information that are desktop tools, plus some other activities such as reporting and configuration of many different aspects of the different several processes. So the idea is that we bring together the power of the desktop tool and the easy and simple ease of use, and also the power of the analysis and the activity on top of the web version. So what we offer in the web? Well, the point is that we are fully integrated with any web requirement management tool. We provide a web extension that it is generic, not tied to any requirements management tool, but it enables the identification on where you are writing your requirement or some other textual assets, identifies it, and then offers you the possibility of implementing our notion of correctness, consistency, and completeness, CCC, to these assets that you are authoring right in the web tool. Okay, so for us, we give you reports in quality, and also we have a possibility to help you while writing the real statement in the other tool by using patterns such as the ones defined in years, in code guide, etc. We will see during the demo part how this works. So, well, I ran a little bit further than expected, but okay, so with the semantic writing assistance, we offer you this web interface to populate any textual input of your tool, and then we assess with the quality rules as assigned to this document your text, and then we offer you the possibility of also authoring the text with the guide of these patterns as we are showing here. We also offer, just before creating the theme, to search for duplicates, to avoid even the management of duplicate elements. So that's real-time saving benefit. So, and in regards of authoring, now it's also possible to trace with whatever other source that you have in your ecosystem. Okay, so it's possible while you are authoring, just you are creating a requirement that it is linked to whatever regulation or whatever other architectural element or whatever, just to link as you are typing the real statement, the real requirement. So it saves time. The user that is populating the requirements or generating whatever other textual assets knows what's the reason for writing that element, because it's related to whatever other document, or because it is derived from a higher level requirement. Okay, that's the point where all the information is in the mind of the author. So why not to put it in the system right now, not later, not by other minds. So we offer trace by author. We'll see that. Also, as we are creating the requirement and with the statement and with traceability, we are able to see the impact analysis just while we are generating. So again, saving time in detecting missing or inconsistency in traces while we write the requirement statement, the element statement. So again, saving time before the actual reviewing process happens. And also, finally, we offer in your tool the possibility to generate two types of reports. The one in regards of the traceability analysis, we generate this report with all the ingoing and outgoing links by different typology, and the quality analysis report on three different aspects: qualitative level, high, medium, low, with some summary of or list of defects just to investigate or to fix, and a quality date, so that you can have an observation point in time where you can see whether you are updated or not. And this is while authoring, and for posteriori analysis, we offer in the web three different tools: global impact analysis, orphan analysis, and semantic search capabilities. The idea is to understand what is the situation of the digital thread in regards of traceability architecture. You see if you have created the suitable relationship between documents to hold the traces. Is the relationships hold in these among the elements are correct or not correct? In regards of the semantics, is the possibility to show what are exactly the relationships that are inside those documents. Maybe I'm connecting wrong type of elements inside one document to wrong type of elements in the other side of in the trace, etc. So we offer you the possibility to have a global map of all the digital thread, to analyze the weaknesses and defects, and to bring this report to the table to improve and to save more time in certification. Orphan analysis is aimed to show what is not shown in the global impact analysis. The missing elements in that map must to be displayed somehow. So we imagine that the best situation is to generate a report on how the documents are in terms of different aspects, in terms of type of relation with other elements, or in the directionality of the relationship, the trace, and so on. So we provide you a report on a number of elements per document which are missing traces of any kind, only incoming or only outgoing traces. And for each of the documents, we are able to show you the orphan elements. So directly, just to be, we can add. Okay, so that's the situation. Of course, there are always exceptions where there are elements that does not need to be traced because they are parts of headings and explanatory comments or whatever in whatever kind of source in a model or in a textual source. So we offer also the possibility to, okay, this element is not to be traced, so please do not use it in the requirement in the orphan report. This is the second tool. Of course, if you feel like the trace is a pain, okay, even though with the web tool, we offer you possibilities on the desktop edition that brings the power of analyzing all the requirement specification, all the different digital assets of your tool ecosystem from many different points of view, and to generate suggestions of traces. So in this way, the activity is performed once for all. The thing is that we have to do it incrementally, iteratively, at a given moment in time, or at the end of the process. And then the tool generated these trace suggestions that can be validated by humans, just to admit it as a valid trait or to discard this suggestion. And also it enables the possibility to store the traces not only in SES Engine Studio, but on another tools, possible tools in the tool ecosystems, such as JIRA or DOORS, if it is the case, where there is entities to store them, okay, in the data model. And finally, the tool for the web that we put at the user's desktop is the semantic search, where the user can look for whatever element in their tool in their ecosystem, project ecosystem, to find whatever kind of asset, for different reasons. First, I can think of reuse in another project. Second, to find missing properties in the actual asset, or for looking for traceability or missing traceability. So we offer the semantic search along with the relationship of to show the relationship to show the element in a documental view. In this view, we can offer you several activities, actions such as impact analysis, list of trace elements, and to see the element inside the hierarchy of each document, especially relevant for very long, deep requirements documents or model-based sources. And of course, this, as an example, this is the result of an impact analysis on a given element that might be changed. So we have to assess what is the impact of changing this requirement in our project. Okay, so we move forward to the demos. Just supposing this little ecosystem, and supposing that in this demo, we are playing the role of being a tier 1 company, where we receive a requirement stakeholder specification for a given component from the OEM in shape of a PDF, okay? And our main methodology is that we develop system requirements using JIRA, and also we develop the system architecture using Cameo, and also we have some other tools for testing, but in the end, these tools, whatever it is, provides a test case report in an Excel format, so we can trace these test case results to the system requirements, and we are going to use this strategy. From the test to the requirements, the relationship is verified. From the requirements, system requirements to the architecture is allocated. There will be also a high-level requirement, lower-level requirement, can be functional, non-functional, transition, or whatever type of requirements. There will be a hierarchy. We use this traceability organizational. And finally, as the starting point, we receive the PDF for the stakeholder requirements. We parse it with the desktop tool, and we link with the requirements we develop in JIRA using the derived semantics. So we are going to showcase each of the 5 different scenarios we explained before. First one will be to show authoring capabilities. So my colleague Iker will show the video recording that we have for this.
Okay, thank you, Luis. So this first video, I'm going to be introducing the RAD plugin, our plugin in the web that we can use to create new elements. In this case, we are creating a new system requirements inside our JIRA specification. Now I'm creating this requirement, and I want you to look in the top right corner where we can see a green icon that it will be the extension, the RAD plugin extension. Now, in a couple of seconds, I will use this plugin to edit the description of my requirement, and in this way, I will be able to use a live quality assessment of the statement that I'm writing. So in this case, I start writing my requirement, and in the left-hand side panel, I'm able to see why my requirement does not have a high quality. In this case, is because I still need the verb, and I have yet to include more information about this requirement. So now, as I'm writing my requirement, note that I am writing a physical property requirement that, in this case, is dealing with a current, and my live quality assessment is showcasing that I still need to add a tolerance value to this volume. So if I add a tolerance, a verifiable tolerance, as Inkos said, and as we know as system engineering, now my requirement has high quality. So now I am able to save it, and I have a high quality requirement in JIRA. We have also another possibility. We have been writing freely these requirements, but we have also have the concept of patterns. Patterns are a guided way to write requirements. So now I'm opening another requirement that has some quality problems, for example, the verb, and also a negative expression. So what I'm going to do is to rewrite this requirement, but in this case, using a pattern, a system property pattern, a maximum system property. Now I'm selecting the pattern, and now as I'm writing, I will have suggestions based on the pattern that I have just selected that will guide me on how I am able to write a good quality pattern, a good quality requirement, sorry. So in this case, as I am writing, you will see the suggestions. In this case, again, it's the maximum weight, and now I have a list with all the systems and elements in my specification, the modal verb that is mandatory, and now I will be writing that the maximum weight of the system shall be 5 kilograms. 5, and now I have also the suggestion for the units, but I can write kilograms and select it. And looking again in the left-hand side of the screen, we see that we still have an error to fix, but it's pretty easy to fix it right now. You just have to write it like this. And again, in the left-hand side, we see that the pattern is matched and my quality is high quality, is good, all green. So I'm able to save it, and I will have a high quality requirement in JIRA. So the next video will be again dealing with authoring. In this case, I will open again this same element. But I will, as this element is new, it won't have any traces, so I will have to trace it downwards and also upstream to the stakeholder requirements, but also to the architecture and to the test cases. Again, I open the plugin and I have the option to manage the traces. Now focus on that the plugin is intelligent and know in which issue I'm working. So I'm able to add a trace. If I click on add trace by document, now I have a view of all the documents that I have connected to my tool. In this case, I'm going to create a trace to the Cameo model. So I just have to select it. And in the next screen, I will be able to change the direction of the trace. This is very important because in my case, I am creating a trace that goes from the system requirement to the model element. And now just by searching the element that I want to trace, let's say that I want to trace my requirement with this power system block or whatever, any other element in my Cameo file. Finally, the trace type, in this case, the trace is allocates, as we have seen in the diagram at the beginning of the demos. And like this is the way to create a trace with a Cameo. I'm going to do it again, the process again, but in this case, the trace is going to be with the stakeholder requirements in PDF. Now, keep in mind that the direction of the trace is the other way around. It's from the PDF to the system requirement in JIRA. So searching for elements that contains the term power, I have these two results, 41 and 42. So I'm going to select both. And again, select the trace type and create the traces. This is the summary for the traces that I have just created. And let's create the last one, in this case, with the test cases, with the use cases in the Excel file. Again, I can search for it. So this way I select it. And again, the process is very similar. Click next. Now I'm able to select the direction of the trace and the trace type. So just by selecting it, in this case, the trace type is verified, so I can create it. And this is the whole resume of the traces that I have just created for my new element. We also have an impact analysis view where we are able to see the whole tree of traceability that we have just created. This is very, very visual because we can see that our the stakeholder requirements derive into my JIRA system requirements that allocate into a model element, and that is verified by this use case number 2 in Excel. We also have the possibility to filter, because these three views can get pretty complicated as our models can be very, very huge, and our traces also. So using the filters, we can see small parts of our impact analysis and only focusing in what we want. And once we have saved our traces, the RAD plugin tool also fills an attribute inside the JIRA requirement. In this case, this attribute is called traceability, and it contains a textual view of the traces that we have just created. But also note that these text displayed in blue are hyperlinks, so we can click on them and we will be able to see which element the trace goes or comes from. In this case, these traces are incoming traces from the PDF, so we can click on the links and see the elements. In this case, for the Excel, exactly the same. Okay, next demo, we will switch to the web application. We are going to see another traceability global impact analysis views and options that we have inside our web application. This is the global impact analysis. This view with nodes replicates exactly the model that we have seen, the diagram that we have seen for our system. In green color, in light green color, we have the Excel use cases. In pink, we have the temperature warrior system requirements. In dark pink, we have the Cameo model. and the other node corresponds to the stakeholder requirements in PDF. Again, we have many possibilities for filtering so that we can see our tree model, our tree view more simply, but we can expand it and see where these traces come and go from. Note that we have in the right-hand side of the screen a column that contains the information of the node that we are clicking on. So for instance, right now I have selected a use case, so I can see the properties and the hierarchy and many other things of all the nodes that are present in this view. Okay, last video now. This video is about the orphan assessment. We understand orphan analysis as traces that are missed that could be missed in our specification. This will be the orphan assessment by document. Keep in mind that each road is a document. The first one corresponds to the system requirements and so on. You can see that our JIRA system requirements have 0% outgoing orphans. This means that all the elements have outgoing traces, but 0.8% incoming orphans. This means that at least one element inside our system requirements does not have an incoming trace. And this could be a problem, this could be a mistake in our traceability, or this could be a missing trace. So if we open this element, we see that this requirement number 27118 does not have an incoming trace. So let me copy the ID because it will be helpful in the future. And now I can see that opening the traced elements, I see that in fact these have an outgoing trace, but 0 incoming trace. Here I can see that we have 0 incoming traces. So this means that this element must be traced, and we do not have this trace created. Focus on this, on the third row. This contains the stakeholder requirements in PDF. We have 1.54% isolated inference in outgoing orphans. This means that at least one element inside our PDF does not have, again, a trace. So this could be a problem. These elements, stakeholder requirement 03, does not have an outgoing trace. So now I'm going to create it directly from the web using a similar process that we have seen before. I can create a trace, but in this case, this trace is from the stakeholder requirement, and I'm going to be creating this trace against the element that we have seen that do not have trace, the element that I have already copied in my clipboard. So now I'm able to create directly from the web this missing trace. I can select the trace type, the direction again, just like before. And if I switch back to the orphan assessment and refresh this, we will see that 0 elements from the system requirements have orphans. Is orphan. This means that all the elements have traces, and exactly the same for the PDF. Last thing I want to show about this orphan assessment tool is the possibility to mark some elements as not need for trace. For example, let's focus on the Cameo model. We see that 78% of the elements do not have trace or incoming trace. So this could be an error, but this could also mean that some elements maybe do not need to be traced. Like, for example, let's say that I don't want all the elements that have element type equal to activity. I don't want this element to have traces. I do not need traces in this element, so I don't want them to be included in the orphan analysis. So just by selecting this check as is traceable element as no, and I have also to include a reason for it, a rationale. What I'm doing is selecting this is traceable element to no in both of them, and selecting them as no need for trace. They will not be taken into account in the orphan assessment. So now if I refresh, this percent has dropped from 78 to 77%. And last video is showcasing the powerful capabilities of the semantic search. Within the web tool, we have semantic search capabilities that allow us to look for any element in our connections. So in this case, JIRA, Cameo, PDF, and also the Excel file. So right now I'm searching for a mode of my system, the attack mode, and I have a lot of results regarding this mode. Again, we can filter, we can use filter by tool, filter by documents, filter by type of element, and also filter by related to. In this way, we can find with a very powerful tool like the semantic search any element that is present in our ecosystem of tools. And again, we can open it. We can also make it white the screen and see all the properties in this table. We will have any additional attribute that we have in our requirements or any additional attribute that we have in our Cameo model. We can also see the hierarchy to see it inside each document. And the most important thing, the traces. That is what we are dealing with right now. Traces element, we have the list of all the traces that this element have, incoming and outgoing traces, and impact analysis. Here we see again a detailed impact analysis, in this case focusing on this element, that is the one that we have just searched for. We see that this element derives from this another stakeholder requirements and also allocate into a Cameo element. Here we can expand to see what other elements are related with this one. This element is related by the stakeholder, but also allocates in another Cameo model element. And again, as we are having in our tools, filters to see a more detailed view. And finally, the documental view. This documental view is the most easy. It's just all the requirements that are present in the document.
Thank you, Iker. Let me go back to the presentation. Okay, so it's going to be time for questions, okay, that you will have generated during the session. So, Cecilia, please, you can.
Yes, thank you very much, Luis and Iker. In a minute, we will start with the Q&A. So if you have any questions or comments, please write them down in the question section. Our next webinar is called Requirements Engineering in the Age of Gen AI, Securing Your Workflows. So why should you join this webinar? You can check how we use deterministic semantic engines to establish a synchronized source of truth, ensuring that any requirement, whether human written or AI generated, meets rigorous ISO 15288 standards or guidelines that's defined in the INCOSA Guide to Writing Requirements. And you will also learn how to safely involve LLMs in the requirements elicitation process while using SES Engineering Studio, both as a writing assistant and a decision enabler to verify the output. The date for this webinar is the 6th of May, and we will send more information in a few days. Okay, so let's continue with the Q&A. Is it possible to generate traces from JIRA to any other source in the system, or only a predefined set of related sources?
Well, okay, this is a good question. The thing is that it depends on the configuration that is set up in the desktop site, the desktop edition of the SES Engineering Studio, in regards of what are the possible actions that the user can do. Means there is always a burden in managing all the possible relationship between the documents. So if the company deciding to deploy this digital thread decides to let the final user decide what are the traceability links that they must be generated, there's possibility for that. But also there is also the possibility for the company, for the project manager, or the quality assurance team, to limit the traces that each document, in this case JIRA, is connected is generated to other documents. So the possibility is both ways, depending on the decision that the deployment in the actual project takes. Just to clarify, in the session, in the videos that we have shown, it was configured not to allow any traceability, including the direction, that it is not had been predefined before in Systems Engineering Studio Desktop Edition. Okay, so the list of elements in the wizard that appear when selecting the other end for the traceability, the other document, the other end, they were only the ones that were related to the document, not everyone. Okay, hope it helps.
Okay, thank you. We have no further questions right now, so let's continue with the next slide. You can contact us whenever you want if you have questions later. So what could this save on your current project? Contact us for more details. You can book a meeting with one of our consultants through our website. We also offer a requirements analysis service to check the quality of your requirements. And of course, you can try our tools for free if you're interested. You can find more information on our website, reusecompany.com, and on our YouTube channel at The Reuse Company. So we'll finish here. Thank you, Luis, Ike, and everybody for attending. We hope to see you soon.
See you.
Goodbye.
Bye.